Now, dear students, we will discuss Doppler's Doppler's effect. Doppler's effect when both sound source and the observer are moving. So this is the case. Let us suppose observer is moving away. Observer is this is our observer. This is our sound source. A vehicle in which a siren is fitted. Now this is our observer. This observer moving away. Suppose with velocity VO, and this is our vehicles with sound source. Now this is approaching toward the observer. Let us suppose this is the velocity of the source. So here VO, velocity of observer, and Vs, velocity of the sound source. And FO is a original frequency of the sound. Original frequency. Whenever both are at rest. Whenever both are the rest, and the frequency, the original frequency of the sound is actually heard by this observer. So FO original frequency of the sound source, and F is apparent frequency when there is a relative motion between these two. So we can call this as apparent frequency. This is apparent, not real ones. It is appear to the observer. So now first the case we take, suppose the case when the observer at rest and source is moving towards the observers. We already know this formula. The apparent frequency, let us suppose the apparent frequency is FO1. FO is the original frequency. Since our sound source is moving toward the observer, it is decreasing the distance between these two. This is the distance between these two. When the sound source is approaching to the observer, the distance between them will decrease. So our apparent frequency will increase. Therefore, FO. So we know that the multiples of FO should be greater than 1. So we can write this one FO, because this is sound source. For the sound source, our denominator will change V minus Vs. So you can see that this is our numerator and this is our denominator. So here this factor is greater than 1. That's why our apparent frequency, this is our apparent frequency, will be greater than FO, original frequency. Now this will be our equation number first. Now in second equations, if I suppose that our sound source is at rest and our observer is moving away, the distance between these two is increasing. So the frequency appear to the frequency heard by the observer will decrease. So in the numerators, in the second case, this is the first case. This is our first case. When the sound source moving toward the observer, towards the observer. Now in second case, the observer is moving away. The sound source. So our frequency will be FO1. It will be our apparent frequency. will be. So now it is moving away. So our denominator will decrease. Our not denominator, it will be our numerator. V minus BO divided by V, and will be FO1. FO1. This is our question number 2. Now, so here FO1 present is here. If I place this FO1 in this place, this one, I will get the resultant values. Resultant value of the apparent frequency which is heard by this observer. So now putting the value from equation of first and second. From first and second, FO original frequency, this is FO, this is apparent frequency, this is the final values. This is also known as apparent frequency, final apparent. I have written this FO2. Now place the value of FO1 from here, from equation of first to this point 2. So our apparent frequency becomes FA, also FO2 is equal to V minus B minus observer, B was the observer velocity divided by sound velocity in air, multiplied FO1. O1 has the value, this one. O1 has the value FO, original frequency, multiplied V B minus BS, B minus BS. Now this B is cancelled out. Finally I will get F0 original frequency is outside, and this is V minus VO divided by V minus VS, B minus VS. This will be our apparent frequency. Now this equation of third will be our final value. Our final value. Yeah. So we have to follow the sign conventions also. Sign conventions also. So whenever the vehicles moving in the direction of the sound, the source velocity should be positive, and it is moving away. If the vehicles are moving away of the sound velocity, it means that if it moving left hand side, the sound velocity, not sound velocity, the source velocity should be negative. So it means that whenever the source moving towards in the direction of the speed of sound, then source velocity should be positive, and when the source moving away away of the sound velocity, then the source velocity should be negative. Now in that case, suppose this vehicle is moving toward this one, so BS should be definitely positive, because our observer is the right hand side, and the voice heard by the observer is directly from the source. The source velocity, the sound source going toward this ones, and vehicle also going to this ones. And whenever the vehicle is moving this side, so you have to put in this place of Vs will be minus Vs, then it will be V plus Vs, because observer is right inside and sound velocity is moving rightwards. So in that case, so here B, our sound velocity, the source velocity will be this one. So here V, sound velocity in air, sound velocity in air